Hello everyone, it's September 14th. Yeah, I think LeetCode is trying to bring in more money. They have this bring LeetCode to your school offer. It says bring 50 or more schoolmates. Then your annual LeetCode premium price will drop from $159 to $99. 30, no 30, 50. If I have the ability to bring 50 people for a specific service, I might as well just start the service myself. 50. And you don't even give me free, you give me 99 instead of 159. I think if I bring 50 people, I think I deserve free. Yeah, we have 9 days left for this. I don't know. All right, let's do this. Find
free for yourself, another 49 people have to pay.
Yeah. Find the longest substring containing vowels in even. I don't even think, who even came up with these problems? Given a string, return the size of the longest substring containing each vowel an even number of times. That is, A, E, I, O, U must appear an even number of times in a substring. Okay. Is this a sliding window? Because it has to be even number of times, so we have a left pointer and a right pointer, and the right pointer move, and when it encounter, that's the thing, when it encounter the first vowel, does it do anything? It doesn't do anything, so it just keep moving until, okay, so the right will keep moving until it hits an even. Okay, and then what? Does it keep going forward? I mean, it should keep going forward. Yeah, you encounter the first one, but how do you know you should reduce? Oh, you count, right? If it's 1, you keep going, and you hit another 1, you keep going, and hit a 2, then you have to check. If someone is 1, you have to keep moving, because that just doesn't work. But what if somebody becomes 3? Huh. Okay, that doesn't work. Yeah, that's the thing, because I don't know when to move the right and when to move the left. Oh, look at this example. The whole thing. Yeah, 0 is an answer. 0 is an answer. I mean, also think about this because we want even, right? So when odd comes, you can set to 1. Even comes, you can set to 0. So it's like exclusive OR. And you have AIOU, that's like 5 positions. So there could be a bit mask, right? Could be a bit mask, as you go through, you hit something, and you set it, right? And you hit something, you set again, and it becomes 0. So when that happens, you can record the length, and then keep going, and record the length, keep going, keep going, keep going. Now, yeah, that's the thing, right? You can keep going, but you never know. Okay, at each position, you will have a prefix bit mask. Are you kidding me? A prefix bit mask. What do you mean a prefix bit mask? Is you do a prefix from position 0 to position I, and you do an AIOU bit mask to represent how many, like if it's a 0 or some mask, right? You have that, and then what? And then so it will be. Oh man, I'm going wild here. This is wild. Okay, so what we're saying is we have at each position, right? At each position is going to be a bit mask of AEIOU, right? And then what we want is for a sub array of that.
You haven't seen another box again, right?
Oh no, I have not. He's digging.
He keeps digging.
Ah.
That's fine.
Are you sure?
I don't know.
So what we want is inside this exclusive OR is gonna be 0. Is this gonna happen? Like, so I have exclusive OR everything here. So at the end, I know which position every number is going to be, and so it'll be something exclusive OR, like all these position exclusive OR, all these position exclusive OR. So what about all these position exclusive OR? So it'll be all this exclusive OR, all this. Ah, okay. Okay. That'll work. Right? That'll work, which means we want to find is I have a value here, right? I have a bit mask value here. And what I want to find is for each position, I want to find the leftmost position whose bit mask is the same as me. Because then if I exclusive with that, I know the rest is 0. All right, so that's a good idea. I want to test it. I want to test it. Let's test on this one. LeetCode is great. All right, so oh my god, that's a very, very long array. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. I have 15. All right, so I have 15. So start the bit mask is 0. So we do AIOU like this. AEIOU. Okay. So at this position is going to be okay, we're gonna write 1 and down, 1 and up. So it'll be 0 1 0 0 0, right? So this one will be 0 0. Yeah, we are at this position 0 0 0 0 0. And here is still 0 0 0 0 0. And this is C is also 0 0 0 0 0. O change 0 0 0 1 0, right? D is 0 0 0 1 0. E 0 1 0 1 0. I 0 1 0 no 0 1 1. Oh, we have more ones now. 1 1 0. That's too thick. S is just 0 1 1 1 0. And G 0 1 1 1 0. GR again 0 1 1 1 0. E again E 0 0 1 1 0. A again. Oh, A is first time. 1 0 1 1 0. T is 1 0 1 1 0. All right, so this is the whole thing, right? So my theory is we need to get each one, try to find the leftmost occurrence of it. So this one, it doesn't have any occurrence so far, so you will be the first one. This one has this at the beginning. At the beginning. But you are a 0 yourself, so we account this is 3, 4, 5, right? So we have 5. Here we don't have any. This is this, so it's actually 1, right? This is actually 1. So this is LEETCO D. Yeah, so it's D is just a D by itself, right? It's just this is a LeetCode. Yeah, it's a D by itself. D by itself because I cannot include anyone. I include anyone, it's gonna have a single. Yeah, so D by itself. This E is also by itself. Now this E that doesn't work because I doesn't have anything. This doesn't have anything. This has by itself. This, yeah, this will have like a 3, 0 0 1 1 0. We don't have a 1 1 0. We don't have this. Yeah. Okay, so let's code this up. I think it works. I think it works very well.
I'm gonna shower. I'll probably leave before I finish.
I'll text you when I leave. Enjoy. All right, so what we want is, ooh, do we even need to create an array for the prefix? I don't think so. I think what we need is the first occurrence. That's what we need, the first occurrence. Okay, so we have A, E, I, O, U, right? That's 5 letters. So the max is 5 1, right? So it's 1 left shift, 1 2 1 left shift 5. It should be like this: 1 left shift 5 minus 1, right? 1 2 3 4. 1 2 3 4 5. Yeah, that's like the length. So we say int array. I actually don't even need int array. No, you need int array. You need a position. So this is the bitmask position. Okay, new int 1 left shift 5 minus 1. That is the count, right? That is the count. Actually, no, I think it's just 1 left shift 5 because I need the 1 1 1 1 1. I need that. So yeah, okay. All right, then we say for char C of S to char array. What do we do now? We do an int mask start with 0 and int result start with 0. Okay. Now A, E, I, O, U their positions. So I can say position. Everybody else's position is. How do I do it? So when I get the character, and I check what is position, which allow me to do left shift. So if it's negative, we will skip. If it's not, okay. So I can do letter, right? Letter position. That's 26, right? And then I say array stuff fill. Letter position of fill with -1, and then letter position for C in. Can I just do this? The string A E I O U like this? I guess I can. Letter position C minus A. Oh, that is not going to work. Okay. Vowels. Okay. Vowels size, length. We say letter position vowels get char at I minus A equal to I. So that is your position. Okay. So we have letter position, then we go from this one by one, and we say shift is going to be letter position C minus A, right? If shift is large equal to 0, then mask will equal to exclusive or equal to 1 left shift. Okay, and then what we're gonna check is I also need array stuff fill bitmask of position will fill to -1. Okay. All right. So what we want to do is we have the current mask, so we check the bitmask position, right? And okay, first of all, if mask is 0, right? If mask is equal to 0, then res equal to oh, that also doesn't work. Damn you. Length plus C equal to char at I. Okay. So res will equal to math.max. Actually, I don't need math.max because it's going to be I plus 1, right? Else mask is not equal to 0. Then what we need to check is actually it should be else if bitmask position mask is larger or equal to 0. Alright. Then res equal to math.maximum res and the current position, right, minus 0, 1, 2. Hold on. If it's 0, 1, 2, then yeah, it's just I minus the previous position minus bitmask position mask. Else, which means then you say bitmask position mask shall equal to I. It's the first time encounter. And at the end, we return res. Okay, let's give this a shot. Let's run one, see how it goes. Okay, this one looks pretty good. Let's use all of them. Okay, I think this is correct. So it's time to, first of all, we don't need this. Okay. Secondly, we will get some comment. 1371. Use prefix exclusive vol to mark the parity of all vowels in S. Our goal is to find the longest substring, longest subarray of the prefix exclusive vol whose exclusive vol is equal to 0. We can keep track, right, of the first time any vowel bitmask, right, appears for the appears, right. Then when the same bitmask appears again, we can use, then we know the subarray bounded by the two appearances have the bitmask equal to 0. The bitmask is a way to mark the parity. For instance, given the position, right, of the vowel as A, E, I, O, U, a bitmask of 11001 means that letters A, E, and U appear odd number of times, whereas letters I and O appear even number of times. So this bitmask positions records the index of first appearance of all possible vowel bitmasks. Letter position records where a vowel, how much, where a vowel, which position in the bitmask a vowel corresponds to. Okay. Bar some weird, actually we can actually do this. A, E, I, O, U. The last one should return 0, which exactly is correct. So we're gonna submit it, and I think we're gonna hit it on the dot. Right, we hit it on the dot. It's pretty confident that it is correct. Call it ON because I don't see any sophisticated, any like brute force stuff. Why is it so easy? they have, 32. Oh yeah. Oh, they just do this one by one. Character map. Oh, wait, what? Oh, I see what they're trying to do. Yeah, a prefix this exclusive or the current character maps. So everybody else is character map. Everybody else is 0 except for these guys. These guys are not 0. They just have different positions. So instead of do a left shift, you get these. Okay, yeah, that's possible. And what's MP? Our MP is the first occurrence. It's the same, right? MP is the first occurrence. And we'll do exclusive or, which is my mask. So we don't have to do another check. Okay, yep, okay. So we're exclusive of that. If this equals -1 and this is not equal to 0, we do this. Otherwise, it will be this I minus MP. Yeah, I mean, it makes sense. Because it sets MP equals -1, so you can do this minus MP. It works. It may be a little bit verbose, but I think overall idea is the same. I'm not going to change it. Alright, that's pretty good. We are 27 minutes in. A little bit odd timing. Do we do this? No, we don't. But I want to recap on what we're trying to do here. So I think the ideal is we will do a DFS starting from any1 as a root, and on the DFS we'll record frequency of the weights for each node. Alright, so for each node we have a frequency. It can be a map or a counter. Yeah, we'll do a counter, right? So for each position we have a counter, which will say the frequency of them. Yeah, counter is actually a good way to do it. And then we have the source and destination. Now the query, we have this query. So we get a query, and we will run this algorithm to find the lowest common ancestor of these two, right? Once we found it, we will do one frequency plus another frequency minus 2 times the common ancestor frequency. And now we'll get the frequency of the edges just between these two, the path between these two. And we will find the maximum frequency of them. And the answer will be the length, which you can call the total. I'll minus that. And that's, yeah, that will be how we do it. It's actually not that complicated. And since I have decided not to implement this one more time, so we'll just copy and paste. Dear me, we're gonna copy and paste this whole thing with some modification. I might need some modification, but basically we'll copy and paste this whole thing, and then we just go through it. Alright, we just go through it, and then we can get this problem over with. We've been stuck here for a very, very long time. I haven't even submitted anything yet. But let's do this for another day. Yeah. Alright, that'll be it.